Ladies and gentlemen, this is Omega, and welcome back to our 3D modeling, CAD, and 3D printer series. So, I need to first attach some photos and send them to myself so I can show you guys what I've been working on. Okay. 3. Okay, that's all done. Okay. Let's come over here, open up my Gmail on my own window. Okay. Okay. We got our images. So, open in photos. Yeah. Why is this zoomed so far in? Jesus. Okay, so this is not the right. Open. Here we go. Here we go. Okay, so throughout the day today, I was making some sketches, doing some brainstormage on the thing we're working on. And this is kind of my final product, which doesn't look incredibly different from what we were already making, but I changed a couple key aspects. One of which, I don't need both of these. This one's better. One of which is, this is only 2 gears wide, not 3. And also, it's going to be modular in multiple parts now, because that'll save me a lot of 3D printer filament if I can use some steel parts, and it'll be kind of cool, considering steel is actually about the same price. So, this is going to be the total frame. So we need, from the floor of the second up, needs to be 7 inches total. So 7 inches on our rods. The ceiling is going to be, do I have a pencil tool here? Edit, here we go. Okay, pencil tool. So, this right here, 2 inches. This right here, 3 inches. Okay, 4 inches, 5 inches, 6 inches. So we need 6 inches for the gears, 1.5 inches on top of that so we can fit them in and slot them in. Then we need the hand crank gear. Actually, this side needs 1.5 inches. So really we need 2, 4, 5 inches on this one. Okay, we need 5 inches at the cap. This one can be a full 7, because it will have some extra stuff running up from it, and the hand crank. And I changed the plans a little bit. So, instead of running flat out, what it's going to do is it's going to come over, go down, over, back, up, over, right there is going to be one large open box. This face is going to be closed, solid metal. These sides are going to be made out of solid metal tubing. And over here, I'm doing things a little differently. So, our final gear is this 90-degree turn, which relays into this one, which then relays into an opposite and powers the piston. I'm going to have the pistons come out the side face here you can see the mechanics from the back side, and I'm going to have these sides be fully enclosed, and this side is going to come up most of the way and have some curvage back in towards itself. And over here was just another example of how instead of 3 wide I could do 2 wide, and it would be more compact and just kind of look better. So let's keep these open. This was some of my part ideas. And let's see if I can figure out. Oh, I can delete projects, yes. Okay. If I close my downloads folder, files, CAD assets. Here we go. Here is all of my CAD assets, STL files. So we have all of the basic parts. There was also one other thing I wanted to experiment with on the STL gears.com, and that is on a spur gear. If I just put a pressure angle of 0, let's go 220, length, I don't know, 20. Let's just see what that looks like. With 0 pressure angle, it's almost perfectly square, which is actually kind of what I want, because the teeth will fit together nicer, they won't have such a hard time. But I do need to check with something. Let's go over here to our buddy, GPT-4. How does hey, bud, can you help me understand how, what is it called? Gear tooth pressure angle affects structural stability and movement. In a system of gears. Absolutely. Gear stuff can be super technical, but once it clicks, it's really cool. Pressure angle is the angle between the line of action and a line perpendicular to the pitch point. Common pressure angles are 20, 14.5, and 25. Okay. So basically, higher pressure angle is thicker, stronger teeth at the base, can handle higher forces without bending or breaking, increased lateral force on shafts and bearings, good for heavy-duty high-load systems, which we're making. Lower pressure, good for lighter loads, where alignment is super critical, okay? Lower pressure, smoother engagement, mesh gradually, operate quieter, less efficient at high speeds. Abrupt engagement can be noisier, which we actually like. Higher backlash, gap between teeth, more play in the system. Better for high speed or high power applications. So, I don't know what that means. What does this mean? What does this mean? Too long, didn't read. Oh. Interesting. It could actually look at a picture of my monitor and analyze. Okay. Thanks. Big help. Okay, let's get back into it then. So the problem with this is where all the force is transferred, the whole tooth is thinner, which means the tooth is more likely to shear here, it's more likely to break at the tip. A higher pressure angle means it's wider at the base and thinner at the tip, which means it transfers force a little smoother, less just of an impact when it hits, and it's much stronger around the base. So let's see what a gear with pressure angle of 45 would look like. $35 is as big as it goes. So we have to do a couple trial and error messages, but it's much easier to build the product here in CAD. I scrapped this idea so this whole project can go after we're done. Let's see what that looks like with a 39. Interesting. So it's more... Okay. That's a 35. What does 30 look like? Okay. So 25 is probably where we want it. Let's delete this project. This can go... This was where we made our parts, and this was the stand we were working on, yeah. So I'm changing this. Basically, instead of being like that... Ooh, that's squooshed. There we go. So, instead of being 3 wide, I'm going to cut it off right here, and it's going to go taller. Be tall and slim with a solid steel frame that's held in place with steel pins. Also, we need to redesign this part. So, we have some basics here we can work with. I will say that. Let's start this. Delete. Yes. Okay. Delete. Okay, let's scale up the blue axis. Perfect. Bada bing, bada boom. Next, let's scale your length. Let's go up to 20 for now. That'll give us plenty of room to work with. So, copy and move. Okay, that would be 1, 2, 3, 4 torque conversions, which is what I'm going for. Now, the fun part. We get to design a handle, which means... Oh, oops. There we go. I wish I could set my camera to a different area. Animation. What does it cost to upgrade to a paid account? Because I'm going to be using this a lot. 150 annual. I'll think about it. I'll have to make some more money before I can justify that. I would like to render physics. Okay, there we go. Now, as for the changes we're going to make, this, which axis is that? The blue one. We need to go scale. Okay, that'll suffice. And the thing about this is I need to do this differently. Which means I need to take this shape cube with the dimensions of just so I can see it. They've changed this so I can't use some of these tools anymore. Well, that sucks. Okay. This is the one I'm going to be buying, by the way. Which has, I believe 16 by 16 build volume. Yeah, they changed. Is this self-CAD? Yeah. They changed this, so I can't use all the same features. Some bullshit. Yeah, they removed a whole bunch of tools from this. Guess we're switching over to building everything in Lychee Slicer. Where did this export to? Downloads. Fix this. Open. Oh, Lord, give me a second here. You cut backspace over here. Paste. You back. You wait. If I drag this over here, does this work? No, I have to extract it first. Oh no. Are you kidding me? Okay, we have to rebuild this. What? Please, top this shore front. That's not front. This is front. I can't move the fucking camera. Okay. Let's start by just separating everything off into the individual parts. That's not even all of it. Hello? We're gonna have a lot to do. Okay, first, we will have to make some stuff in this editor. So, you, specifically. You. Export. STL. Union 1. Save. Okay, let's new project. Create. Okay. Import. Union 1. Open. Okay. Done. Now I need to take this. That is 8 by 17. That's 1 inch. That's 1 inch. So I need a cube that is 6 inches. 1 inch thick. 1 inch wide. Let's change its color to black so we can see what specifically we are subtracting. Hello? I changed your color to black. Okay. Done. Both of you, stitch and scoop. Subtractive, subtract the black one. Wrong. Wrong. Difference. Subtract the black one. Preview. Wrong. Done. This and this. Stitch and scoop. Subtract the black one. Preview. Wrong. Still wrong. No, maybe not wrong. That's fine. Okay. Next. I don't think it needs this port. Instead, what I'm gonna do, cylinder 0.5 and 0.5, height 3 inches. No. No. No, 3, yeah. Okay. Done. Move. Okay. I can't tell. Is that hollow? It is. Oh, because that... Ah, shit. 1. 1. Y'all need to match. Okay. Also... Perfect. Stitch and scoop. Subtract the black one. Preview. Yes. Done. Now, sphere. Sorry, cylinder. Half inch, 3 inches. Done. Rotate. Rotate. 90 degrees. Done. Move. You're supposed to be 0.5. 0.5. Oh. Wait, no. Why? Okay. And you need to be... Long is X? No. Long is Z. Okay. Done. Now, the way I have to do this, you need to be... This gap overall is going to be about 2 inches. I hope. Please. I have no way to know now. That's... Son of a... 1. That's 1 inch. Okay. Okay, now stitch and scoop, unionize. Done. Now that's our solid piece, okay? And what's going to happen... We're going to set the gear in here, slot it over. Then we're going to make another frame that sets and slots down into this to hold it in place. And I'm going to try and have pretty much perfect tolerances here. So let's export this as STL binary. You will be middle base. export. Now, if I delete this, how do I do it? Okay. And I import. I forgot something. So, in the corners of this, what do I do? Okay, I have an idea. Generate. I need to generate a cylinder that is 0.25 and 0.25. That is 9 inches long. Okay. Is half inch. Okay. And now before I do anything with that, I need another cube that is just 1 by 1 by 1. Okay. Now the two of those, stitch and scoop, unionize. Done. Okay. Now, take this, move it over here. Okay. Rotate 90 degrees. Okay. I'll settle for that. Now, grab this, copy, move it to basically the opposite coordinates. I'm so sorry for the copywritten music in the background. There's nothing I can do about that, okay? Now, grab this and this. Stitch and scoop. Difference. Subtract the pillar. Preview. Done. Next, these two. Stitch and scoop. Subtract the pillar. Preview. Done. Save. Okay. Oh, fuck. We've got a part. Now, export STL. Middle base correct. Export. So, file. Now, I open downloads. I grab this, move it over here to my CAD assets. Okay. I'm going to take from here up. Actually, I'm going to take all of that and trash it. Okay. Next. I forgot. Oh no, I didn't forget. I'm okay. So this hole, what I'm going to do is I'm going to have some angle iron run up as vertical supports, and I'm going to have a steel pin run all the way through. Okay. Next thing we need to do. I can't measure this over here anymore. So I have to design the rest of this over here, which is so annoying. Okay. With that, what is your size? Do I have measure? Here we go. Okay. Scale. Okay. Now let's see how big this thing actually turned out. So, fucking course. Wait. No? Give me a second. I have to subscribe to this. I'm gonna need this. I use PayPal for international transactions, and this is an international transaction. No PayPal debit card. 1 USD, $1 is now 80 cents European. That's crazy. Okay, I believe I refresh. I have plus. So now let me just close this and reopen. Slight plus. Here we go, baby. Now, do I have point-to-point measuring? 42.1 millimeters, which is oh Lord. Okay, to make that 2 inches, that's the size we need. Which these holes are now a 1/4 inch. Perfect. God, I'm just that good. How far in are they? They go about a 1/4 inch in. Okay. About a 1/4 inch down. Oh, God, I'm just that good. Okay. What in the fuck happened here? What is this? What is a planar cut? Oh, that's splitting the object down the middle. I don't need to do that. Cancel. Wait a minute. Oh, that just split it down the middle. Okay. You know what I can do, actually, to make sure this is scaled correctly? Cube. 2 inches. 2 inches. Okay, right there. If I set the size to 16 inches, by 8. Is that right? How did I import it? Oh, wait a minute. Did I... Oh, you know what? Scale Y up to 1. Okay. I seem to be having some issues where that exported all kinds of funky. Hold on. Let me try this again. You are now the correct size. You are all one piece. Fuck. Oh, that looks more like it. Yeah, that last one just imported all sorts of funky. Okay, perfect. Okay, let me blow my nose. Okay. Now that I'm here, be insane. That thing is square, right? It doesn't actually look square. Oh no. 2.02. 2.02. 2.02. Okay, so they are the same. It just looks funky because I didn't cut it out properly. But it's tolerable. Alright. We have the base for our project. So here's where the hard math comes in. Paint, paint, paint. So, bare minimum, the size we need. Half an inch. Half an inch. Well, no, this is, yeah, this has a half-inch rod in it. Okay, so that's inch and a half. This is inch and a half. This, 3.5, 3.5, inch and a half. So, that's 7.5 plus inch and a half. That's 9 inches. No, it's not. Because this is, if that's one all the way across, 1/4 inch, half inch, 1/4 inch. Oh, good God. I'll have to scale that up, probably. Let's get these in here. Let's see what these physically look like. Inset internal. Okay. Inset spur, I believe. What purpose does this part serve? Oh no, wait a minute. This is not a part I'm supposed to have. Okay, here we go. Oh, I didn't do the math on this, but if I have... one. Which will then go from there diagonally. Okay, that'll be 1, 2, 3, 4. And each one of these, that doubles force, that doubles force again, doubles force again, doubles force again. Technically. Actually, this one does not, so we need one more transfer. Because this first one is going to be an equilateral transfer. So that's double, 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 times 4. Calculator. So if I put 10 pounds of force into turning it, that becomes 20 right here, 40 right here, 80 right here, 160 down here. So, one turn of this is 2, 4, 8, 16. One turn of this top gear is 16 turns of that bottom gear. We now have to work this out, though. Okay. Rotate you to 90 on the red. Okay. Move you. No. Undo. Okay. So, we now have to scale these down so they fit properly. Okay. Now, what is the size on that? From tip, this one's 187. Okay, it is to get this to 7.5 inches. Bam. Okay. How big is your inside hole? .05. Actually, what is the minimum I need for this to be a half inch? Are you kidding me? That's a half inch now? Oh, fuck. Really? Oh, what? Why? Okay, that's... Now it's... Oh, I'm an idiot. Okay. 12.7. Well, I can tell just by looking at that. That is not correct millimeters. All the way across. Why is that 32 millimeters? Okay, fuck you. Okay, there we go. Now that should be a perfect 1/2 inch by 1/2 inch bar. So, to get U height, let's increase this up to 50 should be fine, right? Yeah. Okay, so to get U, move objects off. To get U to a size, what does your hole look like now? 0.47. Okay. Oh, I'm an absolute buffoon. I'm doing that thing again, ain't I? Wait, no, some objects Y is up. Huh? Anyways. Why are you... You need to be perfectly circular. This is vertical. Inches. 2 inches. You should be 3 by 3. Wait, why is the hole not circular? Generally, what I need to do is I need to make this gear with just about perfect tolerances. I mean, that's just about perfect right there. So, let's make a couple copies of the cylinder. This will take a second because it has to get all of the parameters correct. You know what I'm going to do while this runs? I'm going to launch Vintage Story. This is going to take a while. That's fun. I've been trying to actually buy the 3D printer, and I keep getting turned down for all sorts of payment plans. Mostly because, you know, I have no credit history, so I can't build credit history. They don't like that shit. While we wait for some stuff to happen. I don't think the duplicating actually works. But we'll give this a while to run. Oh, good fucking God. Okay, Elegoo. Ah, shit. Okay. So right here. This is not the printer I want. Neptune 4 Max. A 420 by 420 copy. Paste. 2 inches. Okay, well, it's... anyways, it's got a 16 by 16 by 18 printing plate. So we could make literally anything there. And this will also be big enough that I can do my whole thing. Interesting. Anyways, I just wanted to show you guys which one I'm getting. Yeah, every time I try and duplicate something in Lychee Slicer, it just dies. I don't know why. I mean, we made some good progress on this stream, and I want to take a break. So, I'm going to end some of these tasks that aren't responding. And we'll see you guys next time for more racking my brain. Bye-bye.